Hi everyone. In this session, we are going to simulate half-wave rectifier using LT-Spice software. Before that, let us see the required circuit diagram and the component specifications. Half-wave rectifier. It is used to convert the AC waveform to the pulsating DC using a single diode. And this is the half-wave rectifier circuit. Input side, we are connecting AC source, and output side we are receiving the DC output which is of pulsating in nature, and in between we are using the transformer to step down the high voltage to the low voltage. We can even more simplify the circuit just by taking the secondary side alone. Instead of the secondary winding, we can connect AC voltage source and also perform the simulation. Let us see that circuit. So this is the circuit. Instead of the secondary winding, we have connected a voltage source and a diode and a load resistor. So for the simulation, we are going to use the voltage source magnitude as 12 volts, and the frequency of the waveform is 50 Hz. We are going to use the diode 1M4007, and the load resistor value we are considering it as a 1 kilo ohm. Why we have to use 1N4007? Let us see why we are specifically using this number. It will have the high peak reverse voltage of about 1000 volts, which can safely block reverse voltage from AC. And also it will have a good current rating, which is suitable for the power rectifiers, and reliable and cheap, and also designed specifically for the power rectification purpose. Now in this figure we can see there is a maximum ripple that we are getting for the DC output. In order to reduce the ripple of the output waveform, we need to connect a capacitor parallel to the resistor. Okay, the circuit looks like this. So this is how we need to connect the circuit to get a ripple free output, and the capacitor value is about 1000 microfarad. So we are going to do the simulation for both the circuits. Initially we connect without capacitor, later we place the capacitor and observe how the waveform improves. Click on LT-Spice icon. We'll come to this window and go to File. Click on New Schematic. Again go to File, go to Save As. Give the file name half-wave rectifier 1. Then we need to place all the required components. In our circuit we have voltage source, resistor and diode. We can get all the components from here: ground, voltage source, resistor, capacitor, inductor and diode. Another way of getting components is go to the component library and select the required component from here. The most easiest way is just by using the keyboard. We can select the components. If you need a voltage source, hit V button in the keyboard, and here is our required voltage source, and hit on R, then we can get the resistor, and for D for diode, but we need to rotate the diode. So before placing on the screen, you give a Ctrl R. Okay, the component will rotate. That means together you need to press Ctrl and R. Place it on the screen. So we need a wire to connect these components. So for that, hit on W. Now we can see here to connect these are the guidelines, so which make our job easy. So click on this and connect here. Where to take the turn, these guidelines will give the proper guidance to us. As soon as you come here, we can see it is directly showing where to take a turn. Click on that and directly you go and connect the diode, first terminal, second terminal. And the beauty of this software is we no need to give a escape, to connect from one terminal to the other terminal, and we no need to restart the wire again and again. Once you select, you can continuously connect to the circuit. It automatically takes care of that wiring properly. And once we finish the wiring, now we need to give the values to this. To give the values, you can see here, to bring the circuit into the mid of the screen, you can click this. After that, to zoom in, you can again select this zoom in button. Now you can see here the cursor is changing into two different shapes. So if you are placing on the screen, it is looking like a plus sign, and if you take over the component, it is changing it to the arrow sign. So this arrow indicates that we can enter the values to that. Once the arrow shows up, then you give a right click on the component, and here you just go to advanced and select the sine wave. The DC offset value, give it as a 0, and the amplitude we have considered 12 volt, so that amplitude we have entered, and 50 hertz. That's what the signal we have considered, 12 volt amplitude and 50 hertz frequency, and click on OK. Now we need to select the diode. To select the diode, click, pick a new diode. Now if you can see in this series of numbers available, we don't have the number 1N4007. So instead of that, we can select 1N4148 of a similar configuration, and the resistor value we need to give 1K. So give 1K, say OK. So we need to place the ground terminal. So go to here and connect the ground. So with this, we have finished the connection of the circuit diagram. Now we can run the circuit to see the output. So before that, go to simulation, go to configuration analysis, and here you give the stop time as a 50 millisecond, which is 0.05. And here we can see different types of analysis are available: transient, AC, DC transfer, noise, and transient frequency response, etc. But transient analysis gives the maximum information, so usually we go for the transient. Okay, so we have to bring that transient and place it on the screen. This is our final circuit. Now we can simulate. Go to the simulate, run. This is one indication that we have connected the circuit successfully. Okay, this black window is the one where our waveforms will be displayed. And which waveform we want to see, that I will tell you. This gives the input voltage waveform, and if you place at the extreme corner at the output side, we will get the output voltage waveform. In case if you want to see the current waveforms, you need to place the cursor in the mid of the branch. So this is the current flowing through the diode, and this will give you the current flowing to the resistor. So first let us see the waveforms, because we are interested to see the voltage waveform. So let us click on input voltage. So you can see here the amplitude we have given 12 volt. So the amplitude of the waveform is 12 volts, and it will have the frequency 50 hertz. And let us see the output waveform. So which we need to get the rectified waveform. So that is it will half wave rectified. Only the half cycle will be rectified. So let us see that. Here you can see. So the first half, positive half remains the same, but the negative half cycle has rectified. The small difference in the magnitude you can see, that is because of the drop across the diode. Now if you want to see only the input and only the output also, you can delete one of the waveform. You just suppose if you want to delete the input waveform, which is green in color, right click on this waveform, it will give you delete the trace. You can delete. So you can see only the output waveform. Similarly, if you want to see the current waveforms, you can right click, delete the trace, and you just run the simulation and you can see the current waveform. Okay, so this is the current waveform and this is the current which is flowing through the resistor. So this is how we can analyze circuits. These are the input and output waveforms. Hope you guys understood the concept. Now let us see how to reduce the ripple of the output waveform by connecting the filter capacitor across the resistor. Go to the file, give a save as. Here, give it as a half-wave rectifier 2. So now press the C button on the keyboard. So you will have a capacitor. Place it on the screen. Hit W to pick a wire and connect the two terminals of the wire. So once we connected, now we have to give the capacitor value. So the capacitor value is 1000 microfarad. 1000. To indicate micro, we can give U. Say OK. Now to bring the circuit onto the screen, so you can zoom in. Now we can run. Now let us see the input waveform is of the same. Now let us see the output waveform. So we should get a waveform which is we can see here we are getting perfect DC waveform with a minor ripple. This is how the filter capacitor helps. Okay, so this is how you can analyze the circuit without filter, with filter, how the output waveform of the half-wave rectifier will be. So I hope it is clear. Thank you.